Hey guys, welcome to the video for homework number 5. Just a reminder, B-Days are now ahead of A-Days, so B-Days, your homework is due on Wednesday, September 12th. A-Days due on Thursday, so don't forget, that's pretty soon because I'm making this video on a Monday. Look, there's my to-do list for today. So let's get started. So we are now starting with what is a function. So this is building off of the Barbie bungee jump activity where we had to extrapolate our data from the meter stick to the ceiling. So now we're just doing that in table format. So we have two tables of values. It says for temperature over time, we're going to go with distance over time, make a prediction for what the distance would be when x equals 15. So let me see if I can find a pattern in this first one. So I'm going from 4 to 8, 8 to 12, 12 to 16. I know that we're adding 4 each time. But another way to think about it is we're adding 4 and we're starting with 4. So this also, 4 times 1 is 4. I see that 4 times 2 is 8. I see that 4 times 3 is 12. Shockingly enough, 4 times 4 is 16. So I could write this noticing that my number in the parentheses is the same thing as my time. I could write 4 times x, and I think that would give me a pretty good approximation, right? 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. So 4x would give me a pretty good prediction or a pretty good equation for my future predictions for distance. So I know I'm supposed to be looking at when x equals 15, so I substitute 15 in for x. 4 times 15 is 60. And that's my answer, except I'm an excellent math student, so I'm going to remember to put my units. I'm looking at distance in feet. I'm going to end up with 60 feet. And that's the answer to problem 1. Woo, super exciting. Moving on to the second one. So we have our same thing, time in seconds, 1, 2, 3, 4. Now we have a little bit of a difference because it's not increasing by the same factor that we're starting with. So I'm going to look and see if I can find my common difference here. Notice how I'm using common difference, which is basically treating this like a sequence, right? I can even write this as a sequence, as if we did not have enough of that. So I'm going to write it this way, because that's how I solved it, because when I first did this homework, we were still doing sequences in series, and so I was thinking in terms of that. So, starting with 8.5, how do I get to each of these terms? I notice that my common difference is 0.5. I have my first term right here. First term is 8.5. I know that I'm looking for when x equals 15, so I'm looking for the 15th term. That means my n is going to equal 15, and then my un is what I don't know. So writing down my formula, un equals u1 plus n minus 1 times d, I can fill in everything. So u1, my first term, is 8.5 plus n minus 1 times d. N is going to be 15 minus 1 times my common difference of 0.5. 15 minus 1 is 14. 14 times 0.5 is 7. 7 plus 8.5 is 15.5. Once again, I'm an excellent math student, so I'm going to end up with feet. So 15.5 feet. That's a good prediction for how far it is. Again, if you have any questions on that, you can come to me and Ms. Avra. I solved this 3 different ways, so I'm sure you guys who are way smarter than me can figure out a billion different ways to do it because I learn math from you guys every day. So yeah, basically that's not the only way to do it. So I'm going to do these 3 different problems 2 different ways. I solved it a 3rd way. You can ask me about it if you're interested. Then I'll know you watched this video. Thank you very much. But other than that, let's move on. So below are 3 tables of values for the price of a number of Weasley's Wizard Wheezes items. Make a prediction for what the 20-second item would cost for each store. So we're looking for the 20-second term, starting with Hogwarts. So the first thing I notice is that my term numbers, or my W, are skipping by 2. So I know my second term is 18. I know my 4th term is 21. And let's go one more. I know my 6th term is going to be 24. I don't know what my 3rd, my 5th, or my 1st terms are because it's skipping 2 each time. So I can look at this. I notice that there's a difference of 3. So I'm adding 3 each time, which means this is an arithmetic sequence. I'm adding 3 each time. So that means between 2, I'm adding 3. There's multiple ways we can think about this. What I like to say is from here to here, I have a difference of 3. So I'm going to divide by 2 because I want half. Another way I can think about that, if that what I just said was really confusing because it kind of confused me, I can say 18 plus 1 common difference, 2 common difference, plus 2 common differences equals 21. 2d equals 3, d equals 3 over 2, which is the same thing as 1.5. So my common difference is going to be 1.5. My first term is going to be 18 minus 1.5, which is, I told you I solved this one a different way in my head, so I will add that in my calculator. 18 minus 1.5 is 16.5. That's my first term. And I know that I'm looking for what the 22nd item would cost, so n is going to be 22. So once again, using my formula, un equals u1 plus n minus 1 times d. My first term is 16.5 plus 22 minus 1 times my common difference of 1.5. That is going to give me an answer of hopefully 48, because once again, I solved it differently, but that makes sense to me. I'll type it in. 1 times 1.5 plus 16.5. I did get 48. That's super exciting. So the 22nd item would cost $48. And that would be the value of our 22nd term. I'm going to solve this one the same way. This one looks pretty exciting to me because this is my first, second, third, fourth, fifth term, so we're not skipping any items of Weasley's Wizard Wheezes items, so we're increasing by 1. So here I can see that my first term is 7. I can find my common difference just by looking at the change in the price. So I see that this is increasing by 2 each time, which makes this an arithmetic sequence. And what else do I need to know? Oh, I'm looking for the 22nd item. So n is going to be 22 again. So using this formula I wrote over here, I have 7 plus n minus 1, 22 minus 1 times d is 2. So I have 7 plus 21 times 2. That's 7 plus 42. That would give me a sum of $49. So I know that for Diagon Alley, the 22nd item is going to cost $49. And now we're going to your mom's shop. So this one, I'm going to solve this one like an actual linear equation. So as I'm sure you've noticed, I solved the last two like sequences, and who knew that sequences related so clearly to linear functions? I feel like I've been tricked my whole life because I did not realize that until I started doing these. So when we simplify our linear functions, or rather when we simplify our arithmetic sequences, it kind of gives us a linear function. So we could actually graph out these answers, and it would give us a straight line if we kept n flexible, right? If we were like the same way we would type it into a calculator if we were looking for the nth term that's less than whatever, because we would want to see what the graph looks like for different values, and we could actually graph a straight up linear function, which is what we're doing here. So super exciting, and little did you know that what we did last week would actually be pretty much exactly what we're doing going forward, but just in a more real world setting. So that was pretty cool. But for this last one, I want to make sure I talk through how we would solve this if we are solving it like a linear function in the way that you would have seen in Algebra 2, Algebra 1, all of that jazz. So looking at this, I'm going to find the slope first. So slope, we have y2 minus y1 over x2 minus x1. I talked to a couple of you about this when we were doing the Barbie bungee jump activity. So this is the general formula for a slope. Basically what that means is you take, it doesn't have to be 2 and 1, it could literally be anything. So I'm going to take 16 minus 13, which I see are these two values right here, and I'm going to divide them by the same corresponding x values at the top. So 6 minus 3, here I have 3 over 3 equals 1. So I see that it's increasing by 1 each time. If we were still thinking about this like sequences and series, let's see. So we have our third term and our sixth term, 13 and 16. We see that this is actually increasing by 1 each time. So basically our slope is like our common difference, right? So that's the same basic principle. So we found our slope. I'm going to use what we call point slope form to find this. So the form setup for this is y minus y1 equals m times x minus x1. I know this formula will look scary, but it's actually super useful because we already found our slope. That's one of the parts. And this lets us generate an equation when we know another point. So I'm going to assign this first column. This is going to be my x1 value. And this 13 is going to be my y1 value. The most important thing is you can use any of these points. Just make sure you're using them from the same column. So I'm going to write y minus, my y1 is my price, right? Because price is going to be my output variable. So y minus 13 equals m, which is my slope, which as we know is 1, equals 1 times x minus, what would my x1 value be? 3. So I have y minus 13 equals x minus 3. I want to get y by itself to get a normal linear function in slope-intercept form, so I'm going to add 13 to each side. I see that those cancel. I'm going to end up with y equals x. X minus 3 plus 13 is going to be x plus 10. And this is my linear function. I'm looking for what the 22nd item would cost, so I'm going to plug in 22 for my x. I have y equals 22 plus 10, which is y equals $32. So that's the way that you can solve it using a linear equation. I'm going to scooch the paper over so you guys can see. I'm sorry that I was writing so intensely I didn't even notice. But you can use a linear function in the same way you could use sequences and series to solve this problem. And if you have any questions about the notation, please ask, because I know it looks really scary. But it's really just this way lets you use information you already have to generate a formula more easily, if that makes sense. But yeah, anyways, TLDR, if you have any questions, please come talk to me because I think it's super cool. And I also found 2 more ways to solve these that I thought were pretty cool. And again, I know you guys can figure out more. So if you did it a different way, let me know. Moving on to the ACT problems. Let's start with this first one. Students studying motion observed a cart rolling at a constant rate along a straight line. The table below gives the distance, d, the cart was from a reference point at 1 second intervals from t equals 0 to t equals 5. So that's good because we see that these are increasing by 1. So which of the following equations represents this relationship between t and d? So once again, we could solve this like a sequence. I think this would be a good one to think of in slope-intercept form. So we have y equals mx plus b. M is our slope. B is our y-intercept. Here, what's our y-intercept? Well, our y-intercept is what? It's when our graph crosses the y-axis. That means that when it's crossing the y-axis, that x equals 0. So when t equals 0, d equals 14. So I know that my my y-intercept rather is going to be 14. So that means I can eliminate right away choices B, D, and E because they don't have plus 14. So now I'm just looking for the slope. The slope, remember, is basically the same thing as the common difference. So what is my value, what is my output value changing by each time given the fact that I'm changing my input value? Well, I see that this is increasing by 6 each time. 14 plus 6 is 20, 20 plus 6 is 26, so on and so forth. So my slope's going to be 6. And I'm using t instead of x, that was my bad. That lets us know it's choice C. So let's test this just to see if it works. So I have d equals 6t plus 14. Let's use t equals 4. So 6 times 4 is 24 plus 14 is 38. And that's exactly what I wanted. So I know that I chose the right answer. So 11 is C. Looking now to 25, Alex has noticed that the price of a dozen apples has been increasing steadily. Alex's data are shown in the table below. So we see that the years here are increasing by 1. That's good. That means I don't need to do any rearranging. And the price of a dozen apples is increasing by this much each time. So if the price of a dozen apples over time can be expressed in the form y equals mx plus b, where y is the price and x is the year, what's the value of m? So this one is literally asking for the value of m, which is the slope. And what did we say that slope is the same thing as in terms of sequences and series? Slope is the same thing as our common difference. So our common difference is what this is increasing by each time. So I'm just going to take $6.84 minus $6.75. Type that into my calculator. And I get 9 cents, 0.09. That's answer choice A. So there we go. We literally just solved this problem. And we just had to find the common difference. Look, all that writing, and they literally were just asking you for the common difference. So once again, I think the thing to take away from this side is that you can use sequences and series or linear function formulas to find your answer, and both ways would work perfectly fine. And I think that understanding what a sequence is makes it easier to understand what a linear function is, but that might just be me. Once again, if you have any questions, come let me or Miss Avera know. Otherwise, this is due Wednesday or Thursday, depending on if you're an A or a B day. And I'm about to start the backside video, so don't go away yet. Bye, guys.